All right, 10 minutes past 3 p.m. and we are starting our session. So good afternoon, good morning. I don't know whether it's evening for some people, but welcome everybody to our grand seminar on AI for All, Embracing Equity in Generative AI Models. My name is Millicent Ochieng and I'll be your moderator for today. We are super excited to have such a diverse group of participants and speakers joining us today. This seminar has been organized by the AI for Good Lab and MARI, which is presently Microsoft Research Africa Labs in Microsoft. Thank you very much for joining us. And to kick off our seminar, I'd like to hand it over to Dr. Jackie O'Neill, who is going to give us our opening remarks.
Thanks, Melissa.
Thank you. Over to you, Jackie.
You want me to use a microphone?
That would be great. And we can hear you.
Okay. You hear me now? Is this thing on?
Yes.
Okay. So I'm Jackie O'Neill. I'm director of the Microsoft Research Africa Lab. Formerly, we were MARI, Microsoft Africa Research Institute. And I'm really happy that you're here for our second grand seminar, which is on AI for All, Embracing Equity in Generative AI Models, and it's co-organized with AI for Good Lab. And we have a great set of speakers, and it promises to be a very thought-provoking event. And it's our second grand seminar. We had one last year, which was on the exact title, Large Language Models and Low Resource Languages. So this grand seminar is an annual event, and we use it to try and engage with the wider research community on issues that we really, and topics which are core to our research agenda. So I really want to thank you all for attending today, both the people online, but a very big, special call out to everybody in the room, because I know traveling around to come to these things is a bit of effort, but it's so nice to actually be able to meet people in person. And I think it's a great opportunity to build greater and stronger research connections. As I mentioned, we've recently were changed from MARI to the Microsoft Africa Research Institute to become MSR Africa. And this is really exciting for us because it means that we can focus more fully on our ambitious research agenda around globally equitable generative AI. And so this topic really fits in with our core research agenda. And we have a really big focus on thinking about what does it mean to build Afrocentric AI? What does Afrocentric AI look like? What does it mean? And if you're thinking around these topics, they require deep technical, but also deep socio-technical innovation. There are many questions to answer. It's not something that can be done by any one discipline on their own. And so I think it's really important that we remember that this is a multidisciplinary initiative or investment. You know, we really need to think. So some of the things we need to think about is like, what do we need to do to the actual models? What if we were actually going to build an Afrocentric AI model, what would that model look like? How would it work? What would you need to do? How can we ensure that those things are beneficial to all the users all over the world. But then there's a whole load of other questions like, how do people use it? How does it work on a mobile phone? What would you use it for? What types of things do you want to give to generative AI to do? What do you want generative AI to do for you? What do you want to do for yourself? How do you fit it into your work and into your practice? And then there's a whole set of other questions around ethics and responsible AI. So I think when you look at the whole range of questions, you can really see that like this is something where we need machine learning people, we need NLP people, we need engineers, we need designers, we need ethicists, we need social sciences, we need people who do human-computer interaction. And so I think I've always worked in strongly multidisciplinary teams within the tech industry, building technologies for work, typically. And I think now more than ever, we need to strengthen the relationships between the disciplines and think of new ways that we can really work together if we're going to have a positive impact on the world. And although I'm sure most of you are computer scientists in the room, I'm just going to say you definitely do not want only computer scientists building this stuff, because one of the things that we clearly see with the current models is they don't work very well in the African context. And this goes way beyond language. This is also, they definitely have a language problem, although GPT-4 is getting better and better all the time, but they also have a knowledge problem. And that's because they've been trained on knowledge from the global north, all the documents from the global north. And that's what happens when you leave it to computer scientists in America to build this stuff. So we need to really, really be multidisciplinary and strong. And so with that, I'm going to let you listen to the speakers for today. I actually have to run because it's my son's birthday, but I am going to watch online after for the recording afterwards, because I think it's a really exciting lineup. And with that, I hand it back to you, Millicent. Thank you. Thanks, everyone.
Thank you. Thank you very, very much, Dr. Jackie O'Neill, for sharing with us the insights on the importance of like today's theme. That was really great and quite amazing, right? Thank you very much for kicking us off. So following our opening remarks, I am pleased to introduce our keynote speaker, Dr. Lavri. So he's going to talk about addressing, bias and representation in generative AI outputs, right? So he's the co-founder of Revolution Analytics Limited and principal data scientist at Horn and Company. So I'll stop sharing my screen and I'll allow Dr. Samuel to share his screen. And as they are doing that, I'm going to read more about Dr. Lavri. Please let's mute ourselves. So a little bit about Dr. Lavri. Dr. Lavri Labi brings a wealth of expertise to the field of data science, holding a doctorate in statistics and econometrics from the University of Rostock in Germany, and Masters of Science in Data Science from, sorry about that, yeah, University of Technology in Germany as well. So currently is serving as a principal data scientist at Horn and Company. He specializes in providing strategic management, advisory services for digital transformation, automation, and analytics, leveraging AI and machine learning techniques. I'll just hand it over to you, Dr. Lavri. Thank you. So the room is muted. You should mute your laptop.
Okay.
We can hear you now.
Okay, wonderful. So I say that because of my big voice, I leave the microphone for now, but if someone doesn't hear me, then I can use the microphone. right? So my name is Lavri Labi, as you said, I'm a data scientist, and I'm here today to present to you the subtopic of addressing bias and representation, misrepresentation in generative AI outputs. So that's in the context of this seminar about AI for all, embracing equity. Yeah, I was reading. So yeah, so when we talk about AI nowadays, many think about this product or services. Starting for people who like music like me, Shazam. It's an amazing product where you can identify music by just letter up listening to a small piece of that music, right? This is AI in it, and it has helped a lot of music fan like me to identify kind of music. For drivers, we have Tesla. Tesla is leader in automating driving that use AI in it in order to enable the car to make decision, as well identify obstacle and make decision using image processing and so on and so forth, right? So we have also Instagram that we're thinking about when we think about AI, right? As some, I think especially the young ladies like using Instagram because you can virtually do your makeup using Instagram, yeah? Using face recognition and then transforming the image so that you have your virtual makeup, right? So since last year, we have now, when we talk about generative AI, we hear a lot about ChatGPT, right? And some people even now confuse AI with generative AI. For them, when you talk about AI now, it's generative AI, right? So it is a kind of AI. It is based on large language model. What we have been seeing now, it has faced a boom. Let's say the generative AI, basically the basis of ChatGPT. We can nowadays use it for several applications. So the main application at the beginning is and was the text generation, and it was which is very useful. It can revolutionize a lot of things that we're doing. We can do that faster and sometimes even better, meaning creating PowerPoint slides or writing an email and so on and so forth, right? We have also other applications like image generation, video generation, design generation. Also in the area of audio, you can also like do some short clips using generative AI, including audio and so on. You also voice generation, quite interesting application. Last but not least, for us, yeah. Last but not least, for us who are coders, very important task using GPT is basically code generation. Nowadays, you can use your IDE, as this is where you're developing your program. You just write what you want to have as a piece of code, and it generates it for you. You can imagine how fast you can code using GPT nowadays. It's amazing. It's really a revolution for coders, right? So, and all this, and therefore, every month, there are hundreds of solutions which are created based on this generative AI, based on GPT, right? So therefore, this overview, it's a bit small because it's too much. That's even a sample of it, but just to show that there are a lot of applications generated based on that. For companies, they drive the field to adopt a generative AI, mainly because of the issue of data protection, right? But more and more companies are getting into that, especially in the area of communication with client, using chatbot in order to automate the communication with client, or creating internal GPT in order to retrieve information from the live set of documents they have, right? So meaning that instead of looking in all the documents everywhere, they can just have the GPT question and they get the answer, right? And there are more applications also coming for enterprise. So I will show you one of the applications we have been developing as a company, very interesting in the area of tender management, so that you can also see how useful it is for enterprise to implement generative AI solution, right? So tender management, this company is basically in the area of going to tenders platform, looking for tender, download the tender, look into the document of the tender, extract the requirement, and after extracting the requirement, checking if this requirement are relevant for this enterprise. Once it's relevant, they look for the matching expert, because there's a tender, they have a requirement, and they usually look for expert in order to run a project. So they look for the expert internally in the database, and if they don't find them, they look externally, right? So, and then after that, once they find the expert, they then now generate an offer that they send back then now to the tender platform to apply for the tender. So basically, that's the process they are in. Imagine this process take 15 days manually. You might wonder why it takes 15 days. Because if someone has already applied for a tender for an international institution, you will notice that they have a lot of documents, hundreds of pages. You have like template, you have document describing a lot of things that you have to account for. So if you have to go through this document and look for the requirement, it takes a lot of time. So the second thing that takes a lot of time after checking the relevance, because once you have the requirement, you have to look at the rules of the company to see if it's matched it's relevant for them. Once it's relevant, now you take each requirement and look for the matching expert. And imagine they have a large database of experts that you have to look for. It's not that you can do that just with a key search, right? A keyword search. It doesn't work. You have to get into the CV of each expert and look for if they have the experience required. For example, if you say we look for someone who have 5 years experience in doing such a kind of project. Because everyone writes the description of the project differently, it might match, but it's written differently. So the keyword search won't work. You have to go and look at each experience and count for the number of years done there and add it together to see if it's matched basically the requirement. So therefore, it's time consuming. So at least they take 15 days in order to apply it for it. But can you imagine using generative AI, we were able to finish that to the whole process in 1.5 hours. So 90 minutes, they are done with that. How do we do that? Once the tender is downloaded, in order to extract the requirement from the document, you just send the document to the GPT solution, right, to generative AI solution, and ask the document, basically. You ask the document based on what you want to know, and then you extract the requirement for me. So then now to check the relevance, we have the rules. We also give it as a context to GPT and ask the document if it's matched the rule. Automatically, you get the result. And then once it's relevant, you use the same requirement now to do the search in the CV database, right? And that you ask each CVs if they are matching this requirement. And basically, GPT calculates for you first of all, if the experience is relevant and how many years it is, and add all the experience for each CV. And once you find the relevant one, it's point them out and you take it. So then that way you have the requirement of the tender, you have the relevant CV. Once you put them together, you use again GPT to generate the offer. We have a template. We say we have this expert, we have this this requirement, and this template generates an offer. It does it quickly. 1.90 minutes, you're done with that. So imagine how much productivity they have gone through that. So it's an amazing tool. But it comes also with limitation, right? That we want to discuss today. And which is related to the bias we want to discuss about today. So I have displayed here a conversation I had with GPT in preparation of this seminar, right? So I've asked GPT, what is, give me a list of the countries in Africa where polygamy is allowed, right? And this is the list GPT gave me. As an African, I know that in Niger, there's polygamy is allowed, right? I look at the list, I don't see the polygamy in it. So I asked GPT, isn't polygamy legal in Niger? He said, oh, yes, you are correct. I apologize for the oversight. So it is correct, but he did not put it in the list. So now I want to know why was it not in the list? So he said, okay, it might be due to the bias. Himself is saying that. He said that it's related to the fact that either lack information or is underrepresented. Topic about Niger or this region is underrepresented in the training database, right? And therefore, this bias in the training data result in biased output, so to say, right? And this is one of the examples of the kind of limitation of this tool. And basically, he was able to tell me it is correct because I asked Niger. So meaning that he goes, the sample he was looking at was now restricted, he was able to answer. But when you ask him generally, he cannot answer because you have an imbalance in the data set. But I will explain later on, right? So now, we want to look at where does GPT get this information from, right? So there are different kinds of sources, right? Web scraping, book literature, article and publication, social media, conversational data, open source text corpora, and specialized data sets, right? So we want to take a closer look at the source related to Wikipedia articles. And we say, okay, let's look at who is generating content for Wikipedia. We look at the top 10, which have the majority of the content creation on Wikipedia. The first content creator on Wikipedia is United States. Second, India. Third, the United Kingdom. Then Germany, Canada, France, Australia, Brazil, Japan, Italy. Where do you see Africa there? Nowhere, right? And if these data are used in order to train the model, and other parts of the world do not produce so much content, then you have this imbalance. And that's what is existing, is replicated in the model also, right? So, and this is the source of, one of the source of the training data bias. But in order to understand why, how this is linked to the biased output, we want to look at how does GPT work, right? So therefore, we give here an overview. We have the famous, let's say, transformer model. I think for those who are not in the field, they should not fear. We won't get too much in detail of that, but it's important. When we talk about GPT or generative AI solution, that we display this picture of the foundation paper of the revolution, the generative AI revolution, basically, right? And that foundation paper of iteration is all what you need, right? So, and what has been done here, which is totally different from what was done in the past, is the parallelization of the process and the accounting for the context. Right? So there are the two things, because before text processing was done with NLP using recurrent neural network, which was processing the whole thing sequentially, right? Here we can parallelize the whole thing and therefore use a large amount of data to train the model, right? So I'll stop here for the technical detail. Maybe if in the question session I can still answer this the question if needed. So this is a transformer model, but before getting here, there are two steps which need to be done. Because that transformer model do not understand the text you are sending in. So once you write the text you send to him, you need to tokenize the text. Meaning, it's like taking a big dictionary, replacing every word through by a code, right? So every word of the dictionary has a code, and once I have a sentence, I replace the word by the code of the related word looking at the dictionary. That's all. That's what the tokenizing does, right? Now, once I have this, now the computer can understand. The problem is, if I just look at the tokenized, let's say, sentences, I may not understand some aspect of the sentence. Therefore, there's a need to implement an embedding. So the embedding work like this is just to say, okay, if I have two sentences which have a similar meaning, I want my this vector of numbers to be so that the similarity between the sentences is reflected in it. You get it? So, and therefore, this token will be transformed in embedding, meaning like we take a simple example. A human being, we want to compare human being based on the height and the weight. So people who are heavy and tall will, if I draw an axe, will be, let's say, far up in the space I drew with two axes, right? On the far top. People who are light and short will be on the far right, far left, and that position, right? So in this space, you see they're far away from the other, and then we can conclude they are different. So the more I have someone who is, let's say, not so heavy and not so tall, I come closer to the one who are totally short and totally less heavy, right? And so I use a similarity measure in order to know if they're similar or not. And this similarity measure is derived from the vector space, which is generated using the embedding. I don't know if you get it. So here we have a normal tokenizing, you have a normal vector. There, by embedding, we have a vector that reflects the similarity between the sentences. Sorry to take long about it, but we'll see that why it's useful to understand this concept in the next step. So yes, but we want to take a look at a simplified, let's say, representation of what LLM model do. LLM model, so large language model, yeah, this is, I mean, basically generative pre-training, but the large language model, right? So what do we do there? So you understand why the imbalance in the data set has a big, huge impact in the output, right? So what we do is just predict word after word. So it's a language model. It's not a knowledge-based system also. Just predict the next word. So in this case, we have the text, the boy went to we look for the next word, right? So we have to calculate the probability for all the words which might come after the, right? So, and so it's the conditional probability. Conditional probability, why? Because it's given that the boy went to the is there. What is the probability to have one of these words? We see that the highest probability is with playground. Therefore, the word will be predicted by GPT will be playground. But how do we derive this probability? It's based on the empirical distribution of these words in the training data set, right? So meaning, if in my training data set, most of the texts have the boy went to the farm, the probability will be higher for farm, and then it won't be playground. But if, for example, in the USA, most of the boy went goes to the playground, it will predict playground. That's why the problem in the imbalance of the data set creates a problem in the output, right? But the training data bias, it's one of them. There are several aspects of bias, right? What I've just explained was about the training data. We have algorithmic bias, yeah. I can say like 2 words about it, but then we have to move faster so that I can come to the end. But algorithm bias is basically the algorithm that that are chosen in order to train the model. They are based on assumptions, yeah, and assumptions are dependent on what are the hypotheses, yeah, what we think should be. So I can do that with this assumption, I can do with another assumption. So depending on the assumption, how I can have a certain high bias in the output, basically, right? So another thing is also the human input bias. This is due, for example, we have what's called the reinforcement learning, where human being kind of annotate the data so that the machine can learn out of the annotation, right? And therefore, we can also have a bias here if the people working on it introduce the bias. So, and we have basically certain effect on the output. Yeah, we have like the representation bias. That's also as a consequence of that bias we have in the input. We have the stereotype bias and the cultural bias, right? So which derive from what is happening in the input bias, right? So some of the consequences of this is that there's a reinforcement of the inequities because the data set, the training data set, reflect also the inequality or the inequities in the society, in the population, and is reflected in the model, basically, right? And therefore, that's the consequence of this. We have also the lack of fairness, which then results from that. We have this also can have the consequence of reducing the trust that we have in the model. For example, you can imagine when I ask GPT to give me the list and I notice the list is not full and Niger is missing there. So I'm skeptical the next time I'm using GPT because it gives you the impression that the difference with Google, for example, when you do the Google search, you assess a lot of things. That's when they give you the answer, you assume it's right. Once now you notice, oh, it's not right, you start being skeptical and it can have an impact of you accepting that solution. And I can tell you, we had also to convince, for example, that some of our clients that we can solve the problem with GPT because they're very skeptical at the beginning, right? So, and yeah, those are the consequences we can have from it. And now, the question is, how can we deal with that, right? What kind of solution can we have to deal with this problem? So the first solution we can have is already by the prompt engineering, right? So you can see when we do the prediction is based on the empirical distribution, but the conditional distribution. So, and the conditional distribution is so that you subset your, let's say, your basis of data, you subset it. So if you can structure your prompt in a way that it is limiting the kind of data you use in order to answer your question, you have less bias due to this imbalance, right? So you see that as soon as we ask him, is Niger, is polygamy allowed in Niger, he could answer because it's there, right? But we say, give me a list, he doesn't answer. So with prompt engineering, we can do something, but it has its limitation also, yeah? But some problem can be solved with prompt engineering. I think I need a bit of water. My voice is getting so. The second thing is RAG. I mean, some of you may have heard about it. It's retrieval augmented generation. So I won't get too much into the technical details of it, but here on the right side you have an example of architecture of RAG. So the idea of RAG is to say, okay, this model has been developed on data set which are not accounted for our data, right? So, thank you, man. Sorry for the interruption. So, which are not accounted for our data. So here we say, okay, we have our own data, we want to account for it, right? So every time we question GPT, say, take our document and look in it and give it the answer using our document, right? So that's all what is done here. The thing about the vector database, it's related to the embedding, right? So we transform the text in vector and we keep it there. And instead of taking all the text that we have in our database to give to GPT to answer our question, we look for the part of the text or the part of the document which are similar to the question that we are asking in order to extract this text and give it to him to answer. So that's why we need the information in the vector database with the embedding in order to do that. Because with the embedding, we can already calculate the similarity, right? For the statistician, you will know there's the calculation of similarity based either on distance or similarity measures. That's what we basically do before sending that now to the GPT. So it's a solution for bias. Or another alternative is, but it also has its limitation. Yeah, it's also has its advantage and disadvantage. For example, if you use it live, it takes a lot of time in order to answer because he needs time to retrieve the document where the information are stored in order to answer the question. So, for example, this problem you don't have with the fine-tuning. So fine-tuning means we use new data in order to adjust the weight of the model related to our data. We not retrain, but we continue the training, right? So because you can imagine, let's say a neural network train the data in a way that you input data, it does the prediction, it look at the prediction, and with the original data, it calculates the error and spread the error back. In case of backpropagation, spread the error back on the weight in order that for this error not to happen anymore. So when you bring some more data, it continue training and adjust the weight in order to don't have the error for your data, basically. So, and the last thing is just to use human to correct the error, yeah, which I've heard that actually a lot of people have been using Kenya in order to develop ChatGPT, right? Or very small money, being like cheap labor in order to do this annotation. Yeah. So, but yeah. This is what I was showing before is what we can do. I was saying export, that means the model is already there. How can we deal with that the way it is? But there are things we can do actually before the model is trained, right? So one of the things we can do is like first even look at detect the bias. Yeah, bias detection are different methods for that. No, we can use fairness matrix. We can do a disparity analysis, and then assess if there's bias in it, and then deal with the bias while developing the model, basically. So you can also use a feedback mechanism. So, and in order to mitigate that, there are different techniques here, and diversity-aware training, data augmentation. For example, if you see we have the amount of data from largest to small, how can we artificially augment the data compared to others so that we don't have this imbalance anymore? Adversarial debiasing, so while looking for the weight that you account for this bias to adjust the weight of the model, right? So, and last but not least, also very important, often we have this problem with machine learning, with AI, that people do not understand. It's not transparent how the decision is made there. It's a black box. So if we find a way to make it more transparent, how the decision is made there, people can then now identify where the origin of the bias is coming from. It's easier than also to mitigate that, right? So I think I will come now to the closing point of my presentation. I hope not exceeded the time too much. But what we want to say here at the end is say like GPT or generative AI, it's an amazing tool, amazing solution. You can do a lot of good things with that, but it also has its limitation. As we say by us in Ivory Coast, there's a saying when you use your knife to cook and it cuts you, you don't throw the knife away. You clean it and you keep it because you will use it tomorrow to cook again to feed yourself, right? So the same knife which is feeding you, it can hurt you. But if you know how to deal with that, you will always have the positive out of it, right? So similar to what we have here with generative AI, it is very useful, but it has its limitation that we have to deal with. So thank you very much. And if there are questions, feel free to ask.
Wonderful presentation. Thank you very, very much, Dr. Lavri, for quite an insightful presentation. We will allow a few minutes for questions for Dr. Lavri. That was quite an informative talk. Many thanks, Dr. Do we have questions for him?
Yes, I think in Kenya we said asante sana daktari. So thanks for the good presentation. I like to you started by demonstrating a tender system and then talking about the biasness. So something came up due to the biasness. You said your GPT will go through the expert, that is the submitted tenders, against what was advertised. And then for us also who are expert who want this tender, we'll also use GPT to generate proposals. So we go through what you have stated again, and then we make sure that you have stated it. Will that now not lock out the real expert, and then you have the GPT expert? At the end of the day, you don't get the qualified. How are you planning to cap that? Maybe like, are you planning maybe to do scrapping, web scrapping, say that you go through the entire and hear what the people are saying about these companies and so on? Or yeah.
Okay. So if I may reformulate your question for myself, you say that our solution use GPT to optimize the search, but at the same time, the expert use GPT to optimize, let's say, their CV or their presence online. And therefore, we are dealing with two optimized things where we may not have the possibility to find the right people. Yes, that's a very good point. I think part of the answer to that is this company have dealt with people over the years, and they have grown a database of experts, whereby they have CVs of this expert, and they have a track record to some of them they have done project with, right? So when they look in their own database, we may not have a problem. But even though everyone, when he generates his CV, optimize it, that's clear. Then they always, independently if you optimize with GPT or not, you optimize the CV, right? But we are looking for a certain kind of information. We just replicate what the human being would have done looking at the CV. So if there's a problem with optimization of both sides, with GPT, we have the same problem. Where the question is actually very relevant is like things are done now higher speed, right? And if it's done now higher speed, how to deal with that? Because before it was a slower speed where the adjustment which were possible. But that's something that we need to look at and see how it's come out. But for now, the client is extremely happy with our solution. And they take let's say some head front, how do you say that in English? Front compared to the competition in that area.
Yeah, maybe let's take one from online, and then we move to the spotlight talk. So, Dr. Lavri, we have a question from Clement, and he's saying, you said you use ChatGPT to help in awarding tenders. I didn't understand that part. Was there a chance that you could miss out on a good candidate due to the bias of the model?
Yes, that's possible. That's totally possible, because basically, if we are operating in case, it depends where the CVs are coming from. Let's say if we are operating with the CVs from Europe, where a lot of countries produce content for the web, I think some aspect may have taken into account. When we are dealing with CV, if we are dealing with CV of individuals from countries which are not big generator of content online, then we might have, it can be possible to have certain kind of bias. But we need to say also, there's also something in common and there are differences, right? Where the common thing will be well taken into account and the differences may lead to basically bias. But to be sincere, something that we have not directly analyzed. And this, as we suggested in this document, human interaction, annotator, and so on, we're expecting then feedback for the client when they're using this solution to tell us, oh, be careful here, that's the decision is coming like this, but we know that it's like that. Because the client is not using the solution fully and giving up on the manual check. The process of introducing, let's say, an automation solution like GPT or any other automation solution, there's a time where both solutions are running parallelly, and they check, they monitor how good is the new solution compared to what they have before, right? And then move forward with that. And the more they are confident about the answer coming out, the more they're using and leaving what is done manually. And the feedback coming from the manual check is taken into account in order then to fix the limitation of the model.
Thank you very much, Dr. Lavri. I'm being reminded by Marcy that we have lots of questions there, but then I'd like to ask people joining us there in person to actually connect with you due to time. We have to move to the spotlight session. And then for the people joining us online, someone is actually asking if they can connect with you, probably via LinkedIn, to ask you probably for guidance with their masters in machine learning related problems. Are you okay with that, Dr. Llama?
Sure. Yeah, sure, I'm okay with that. Yeah.
Perfect. Thank you very much, everybody. And I know we wanted to ask lots of questions. It was quite informative and very, very insightful. Many thanks again, Dr. Lavri, for that talk. Next, we are going to have a spotlight talk given to us by Stanslaus Mwongela. So Stan, if you can come on camera, please. Stan is doing quite amazing work and it's on UlizaLlama modeling a safe and performant Swahili large language model on a budget, right? So he's a machine learning expert at Jacaranda, Nairobi, Jacaranda Health, right? Nairobi, Kenya. Stan, please come on camera and also on mic, and then let me stop sharing to allow you to share your screen. And as you're doing that, I'll just read a little bit more about you so that our audience can get to know you better. So Stanslaus is a machine learning expert at Jacaranda Health. Unwaveringly devoted to enhancing healthcare outcomes for marginalized communities here in Kenya. He's currently pursuing his doctoral degree in computer science at Strathmore University. Stan also holds the role of machine learning engineering manager at Jacaranda Health, where he's harnessing the power of AI to uplift the healthcare standards for underprivileged mothers. And that's what he's going to share with us. So excited about it. Over to you, Stan.
Thank you so much, Millicent. I think you forgot to mention that I'm a former intern at Murray. So I did my internship for PhD at Murray way back in 2022. Yeah, and actually this is what actually accelerated my research journey towards natural language processing. So it's a pleasure to meet you all. So today I'm going to present UlizaLlama and also UlizaMama, which is the maternal and newborn health fine-tuned version of the same. The goal being, how can we be able to create low resource large language models using tight budgets and also fewer resources. So you're going to look at how we have been able to leap into large language models using some of the most common techniques, but we're also going to explore some different design choices when it comes to this. So the order of my presentation, so I'll start by doing some context of this work. So why is it important? Why should you care? Why are we trying to do it? Then I'll move to training methodology choices. For continued pre-training large language models to understand these low resource languages. Then I will also look at some trade-offs when we're also trying to look at continue pre-training. Then we'll also look at the evaluation methodology, which we are using in this work. And then I'll also share the evaluation results. And lastly, some few inference examples to see how this model actually performs. So for those of you who do not know Jacaranda Health, so Jacaranda Health is based in Kenya, but also has a presence in Ghana and Eswatini. So the organization works to improve maternal healthcare outcomes, and especially for underprivileged moms and babies. Right. So I want to start with a story, and I want to start with a story of the mom, Josephine. So Josephine is that trimester mom, and she's based in Kisii, which is largely a rural part of Kenya. So one late evening, she starts experiencing some bleeding, and she ignores it. She thinks this is not very serious, so she delays seeking care. So, but this bleeding worsens, and she's forced to go to healthcare facility. But the nearest healthcare facility, being in a rural part of Kenya, to get there takes like maybe around 1 hour. And when she arrives at the healthcare facility, further delays occur. For instance, she needs some transfusion, and a correct blood type may not be available. So Josephine is not alone. Actually, a third of maternal deaths in Kenya occur due to delays in seeking care. And that's where we come. And that's where Jacaranda comes. How can we ensure that moms can be able to get the right information at the right time? So, and we have this product called prompts, which usually starts with a chat. So a mom usually signs up in a healthcare facility, and then there's a key code where she texts and to enroll, and then also based on a digital health record, which we collect from the questions we ask when you're trying to enroll, we're able to identify some key issues. For instance, we can be able to tell whether she has a preeclampsia. We're also able to tell if this is a second pregnancy, etc., and also some further complications. And from that, we start sending them messages which are targeted towards improving their health-seeking outcomes, and also for them to also learn how to identify danger signs. So we empower them with information. For instance, danger signs they can look for, and different things they can watch out for. So this is how the messaging works. So for instance, it's most of the moms we have actually do not have a smartphone. So because we are mostly targeting vulnerable moms. So how do you ensure that these moms actually get the correct messaging? And at the same time, how do you also ensure that they can also talk to you in a very efficient way and also be able to respond to them in a very personalized way? And that's what actually prompts seeks. So prompts is mostly based in SMS, but soon we're also trying to integrate it with WhatsApp. So it's a personalized digital health navigator, which also has things such as appointment reminders. So we send them some SMS nudges on their next appointment for their baby's next checkup, their antenatal visits, etc. And we have been able to see some impact with this tool. For instance, 27% of moms who are on prompts are more likely to attend 4+ NC appointments. And moms who actually on prompts also 2 times more to take up on different methods of postpartum family planning. So in a typical day, we receive over 6,000 questions. Actually, when you include surveys, this could even extend to over 20,000 questions right now in a typical day. But the challenge is now trying to find the red flags in this high stack of questions, because you're having people who are trying to ask about is it okay to eat avocados while pregnant? Well, at the same time, you have a mom who is having a very serious issue such as bleeding or decreased heart rate. So ML, when we receive these questions from the moms, as you can see, they're just trying to send them via SMS. We use some AI-based strategy. Actually, this is what we call our hierarchical model. And part of the work of this was actually improved while I was doing my internship at Mari. That's actually how I got to know Jacaranda Health. So this is actually what happens. So a message comes in, and then in the first level, we're able to identify if it's headache, and then in the second level of the hierarchy, we're able to tell whether it's a severe headache or a moderate headache or a mild. So we have like 176 categories, and these categories have all been assigned some priority level, and this actually now allows us to be able to now tell which questions should we address first, because if you are going to fast in, fast out methodology, it would mean that we will not be addressing the danger sign questions in time. So now the challenge comes here. So currently, even for these urgent cases, because it's humans who respond, so we have like some trained human help desk agents. It usually takes like 5 minutes to respond to some urgent case. So 5 minutes is quite a lot. So how can we be able to reduce it? And that's when we started looking for solutions. Can we be able to actually receive this question, generate some answer from using maybe another model which understands the context? And remember, the context of the language you're dealing with is Swahili, English, Sheng, and also very low resource languages, and just like multiple local languages, which words also find themselves in the messaging. So yeah, that is a challenge with the type of language you're trying to deal with. So, and that's where our journey for exploring how to use large language models to address the questions asked by moms started. And yeah, we saw that this would be maybe the best opportunity for us to also reduce the response time for urgent cases and also hold the other cases. So, but then we also tried some off-the-shelf LLMs such as ChatGPT and all. And there's this question which was written by mom actually in Sheng, and it was about fetal movement. And we gave it to these large language models and also added some form of context. But the generated response was on a baby playing. Then, exploration again, we decided to look whether there were open source LLMs which could actually understand Swahili, and we could just simply fine tune them, and they could respond well to these maternal health questions. And funny enough, we were not able to find any of the models good in Swahili at the time. So, and I'm trying to show you these are actually the most performing open source large language models, especially for the 7 billion parameter model. So if you extend it to more than 7 billion parameter models, of course, you'll get mixed trial and all that. But yeah, when you look at the blue score, as you can see, when we try to evaluate it with the Jacaranda MNH Swahili, so we have this validation data of the responses given by our agents. And then we try to look at the responses these given models give, like Girmaw, Mistral, and Llama, without fine-tuning them, just doing a very simple experiment, like a 5-shot experiment where you're trying to show them like 5 examples and then asking them now to actually predict the answer. So you can see the blue scores here are very, 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 very low. Blue score is like an exact match score, but again, you also have the black score, which tries to look at the semantic similarity. And also we have the meteor score. So these meteor and blue, I don't know if it's meteor or meter, but yeah, these are the metrics we try to use. And as you can see, the open source LLMs are actually failing with our MNH Swahili benchmark. Now, so what's our training methodology? So I'll start with this simple diagram here, but what we see is like there are many paths you can take when it comes to actually getting to the goal, which is UlizaLlama. So for UlizaLlama, of course, it's very easy. So first is continue pre-training using Swahili. So we were able to extract a very large Swahili corpus in our phase. We are lucky, actually. There's a lot of data on Swahili, which we can use to train large language models. So the length of that was like 340 million tokens. And we'll also discuss some of the other considerations we met, like if whether to go for full pre-training versus whether to go for frozen pre-training when you are trying to do the continued pre-training for Swahili, and also whether to do tokenized extension or not. Then we continually pre-train the foundation model. So first is the Llama model and also the Mistral. So we have also tried Mistral. So we continually pre-trained it to understand Swahili, and it was very good in trying to predict the next token. So the task is just to learn how to predict the next token in Swahili, what you call the causal language modeling. Then we also did the instruction fine tuning of this given checkpoint now, for it now to understand instructions in Swahili. And for instruction dataset, we actually took some existing instruction datasets in English and translated them to Swahili because there were no existing instruction supervised fine tuning instruction datasets for Swahili then. But so that we can also lessen the forgetting on the English task. So our instruction dataset was mixed with Swahili and at the same time with also English. But then we also realized that there was also a need of also trying to ensure that whatever Swahili model you're going to deliver is also very safe. So we also had to look for safety datasets. So we got one from Hugging Face. It's called Beaver Tails. Yeah, we got like over 14,000 prompts and generated safe responses for these using GPT-4. And this was also part of our instruction fine-tuning data. And this gave us UlizaLlama. But of course, there are other different things you can actually do before you get to the final thing. Maybe do some reinforcement learning. But anyway, so to move to UlizaLlama, which is now the maternal and newborn health model, which understands MNH questions, we had to look at different design choices. which we are still looking at, and which I'll also ask the audience here to actually also analyze and maybe tell us which of these design choices you think would work best, yeah, given our use case. And yeah, and maybe one thing to note is the reason why you also don't want to use maybe models such as MedPalm and all that, it's because the language which you want to interact with moms, it's the language which they can be able to understand. So you don't want to use a model which is going to be very technical with the moms. You want it to, the reason why we also do fine tuning, it's also for it also to level the language to the understanding of the mom or a lay person. So to move to UlizaLlama, so we take the checkpoint which we continually pre-trained using Swahili, and then now continually pre-train it using our MNH data. So we have a data set of like 1.3 million questions and 1.3 million responses to maternal health questions. We also have like some knowledge base on maternal health issues. So this is the kind of the data we use to continually pre-train for MNH. This is a given checkpoint here. Then that checkpoint there, we needed to now instruction fine-tune it. But remember, our MNH instructions are also not very, very, very good. And at the same time, we also want to have an intelligent model which can actually capture the context well. So in the next step of instruction fine-tuning, we opted to now mix our general domain instruction data sets with our MNH instruction data, because when you look at the MNH instruction data, like the questions and the answers we have, they're just like question answer. They're not like very proper instructions. So, but if you're able to actually mix this data, you can actually have some learning on how to, the model can learn how to handle different types of instructions, and also, especially if more context is added. But the way you're trying to do this instruction fine-tuning in this step is you're trying to do it in a language-fast instruction fine-tune. So first, do the instruction fine-tuning for it to first understand instructions in Swahili and English, and then now do the instruction fine-tuning to understand maternal and newborn health instructions. Then the last stage is the direct preference optimization. So where we look at what the model said versus what the agent, the best response from the agent, and this allows some reinforcement learning for it to actually lean towards providing responses which are closer to the human preference. But as I said, that's not only the design choice which you can actually adopt. So I'll move to the next design choice, whereby instead of doing this step of language fast instruction fine-tuning, you take the so you see here we use the continually pre-trained model, which is like a foundation model. But here you're trying to take the instruction model, which is actually the UlizaLlama, and then now do the in-domain pre-training using the MNH data. Then instead of doing language fast instruction fine-tune, we move straight to instruction fine-tuning using the MNH instruction data. And then the rest of the steps are the same. So that's another way of also trying to approach it, but you'll tell me what do you think is the best approach. So let's label these as 1, these as 2. And now in the third approach, now we continually pre-train using Swahili, then instruction fine-tune using both Swahili and English. Of course, you get the UlizaLlama. But the difference here now is we take this model, we don't continually pre-train. So what we remove here is we remove this part of in-domain pre-training and move directly to in-domain instruction fine-tuning with our maternal and newborn health instruction data, and then do the direct preference optimization. So the goal being getting to UlizaLlama. So that's design choice 3. Design choice 4. Now, we move from the instruction fine-tuned version. That's the UlizaLlama model. And instead of doing the instruction fine-tuning, and also the continued pre-training for the maternal and newborn health, we do some direct preference optimization fine-tuning using the MNH preference data. Still you get to UlizaLlama. And the last one, the last design choice. So you continue pre-train, but now these are different methodology. So you continue pre-training the model to understand Swahili, but at the same time, add SFT resampling, supervised fine-tuning resampling, MNH data. What do you mean? You're trying to add some data which looks like instruction output, like question answer, but for pre-training purposes, not for instruction fine-tuning purpose, but you want to put that kind of data during the pre-training phase. The same as also the Swahili instructions, you also want to add them there. And then I'll do the DPO fine-tune MNH preference data. Then do the DPO fine-tuning using the MNH preference data. So those are the different options, but there are more than these options. And I would love you maybe in the chat, maybe later on we can look at, you can tell me what do you think actually works. If you want me to go back, I'll actually go back later on. Now, so the other design choice you had to make was our continued pre-training strategy. Do we want to do some full pre-training? So fully pre-train all the layers and embeddings, or do some frozen pre-training, either using QLoRa or LoRa. So maybe based on the empirical research we did, if you are trying to actually do this on a budget, you go for frozen pre-training, and here you're trying to actually compare whether you are going to do this using QLoRa or LoRa. So these QLoRa and LoRa are parameter efficient techniques which allow you to freeze the base model parameters and only fine-tune very few parameters. And most of the times, actually, when you use this strategy, you can also achieve the same performance as a full pre-training. So this is actually achieved at a lesser cost and also less timing. When you're also trying to do that pre-training, you're also going to do it in less time. And when you look at the difference between QLoRa and LoRa, and mostly you'll see that with QLoRa, you're able to fit even larger batch sizes, even in the typical small GPUs such as V100 and also L4. But with LoRa now, you have to use maybe at least A100 GPU for you to be able to do this frozen pre-training, and you're not going to fit a lot of batch sizes. So with QLoRa, you are just trying to quantize a model. Maybe it was a 16-bit and you want it to be like a 4-bit model. But the thing is, both techniques usually achieve same form of accuracy. So depending on your strategies, they can achieve same accuracy, same performance. But with QLoRa, you train longer compared with you trying to go for LoRa. So the other design choice, which is also a very interesting design choice, is whether to extend the tokenizer or whether to use the original tokenizer. But I'll say first, this depends on the language you're trying to fine-tune for, and also the vocabulary of the existing tokenizer. So when you look at the vocabulary distribution of the existing tokenizer, you're able to tell whether are you going to go for original tokenizer or are you going to do the extended tokenizer? Because when you extend the tokenizer, you're going to shift the embeddings in some way, and because of the you are trying to shift the token embeddings, if you don't do it well, you might encounter some issues such as forgetting evaluation. And that's why if you're going to opt for doing any extension of the tokenizer, you have to consider how you're going to initialize your embeddings after that tokenizer extension. And some of the techniques people use is averaging existing embeddings, but there's this option of also trying to also randomly initialize the embeddings, which is not as optimal as averaging existing embeddings. Now, for Swahili, based on our research, it's actually better to not extend the tokenizer. We actually extended tokenizer, got very good results actually with the UlizaLlama, and we could see it performed very well in Swahili. But when we did some other more evaluation, we actually saw that there's some form of forgetting, like a catastrophic forgetting for the English task of the original foundation model, which was Llama. So the extension of the tokenizer led to some degradation of performance in English, as I'll also share in the results. But using the original tokenizer and continue pre-training using the original tokenizer, because when you look at Swahili and also the vocabulary in the Llama 2, you'd find that there are not so many out of vocabulary tokens. So most of the subwords there are sufficient actually to work with Swahili. Now, again, do you go for just the normal forward pass, the ones which are in the current build models such as Llama and all that, or is it better to go with a mix of experts? And I know this is also a very easy one. So, but it also depends. So if you're going to go for a mix of experts model, you also have to take into consideration how big do you want your model. Okay, you have to take into consideration the size of the model, the size of the resulting model. How big should it? How big should it be when you continue pre-training it or fine-tuning? Do you want 30 billion parameter model, or do you want a 7 billion parameter models? And we noticed that if you wanted to do fine-tuning for Mixtral, which has these forward pass with a mix of experts, the resulting model will actually be very, very, very big, and still a 7B parameter model worked fine for us. But we've also seen that there's also these Llama mix of experts models, which have also been released, and they're also smaller. This could also be something which we would want also to explore. Now, on the evaluation methodology. So for evaluation methodology, so we are splitting it into different 6 stages. So the first stage is just trying to do some baseline models, language task evaluation, as you saw the first slides when I was trying to compare the open source LLMs. So we look at the leaderboard and see maybe the leading models, and then try to see how well do they understand Swahili. But now for this, we use these auto-evaluation metrics such as BLAT, BAT, BLUE, and BAT score. Then the other evaluation we also do is the forgetting evaluation. So, and this actually informs our continued pre-training strategy. So we want to ensure that we are not degrading their performance on the original language, which was there. And for this, we actually use maybe the existing benchmark. So we just try and see if Llama was performing these on the benchmark MMLU or truthful QA. Is it actually is this performance actually reducing when we use this continued training strategy with Swahili? Does it reduce, and why does it reduce? So we go back to the pre-training strategy to see the best ways of actually avoiding this forgetting. Then the other stage we look at is the Swahili language task evaluation. So this is still a work in progress. So, and our approach is to translate the existing benchmarks, because we've not found an existing benchmark for Swahili language task. So we want to take different benchmarks such as MLU, Truthful QA, GS8K, Ella Swagen, all that, and do translation to Swahili, and then later on tell how Swahili is actually performing on that. Then auto-eval metrics, but now mostly this lower part here is mostly for the UlizaLlama model. So for the UlizaLlama model, so first you want to do the auto-evaluation metrics using BART score, BLAT score, BLUE score, and also the Meteor score. So BART score is for semantic correspondence, mostly semantic similarity, same as BLAT, whereas BLUE and Meteor score mostly related to exact word matching. So what happens when you're trying to do this evaluation? So you need what you call the candidate response and the hypothesis response. So for instance, you'll have our model response. So let's say we have trained our model using 2021, 2022, 2023 MNH data. So we want to use the 2024 data, maybe for 1 month or 2 months, to form our validation data. And of course, you have very good responses there, which are from our human agents, or human help desk agents. So the same questions we are going to give our models, and then they're going to predict a response, and then we're going to now to compare those, our response versus the response of the agent, and see the difference using these scores. Then we also developed another tool, and this was mostly for doing the semantic evaluation. So this is our own created metric, what we call GCM, GPT assisted score. So GCM stands for grammar, correctness, and medical accuracy. And actually, this is actually inspired by the evaluation metric, or the auditing metric, which is used by our quality assurance team at Jacaranda Health when they assess the responses which our human help desk agents give to moms. So using that criteria, we were able to build this given score, and now we leverage on a large language model which understands Swahili to rate it, to rate the responses according to this given metric. So the last form of evaluation which we are implementing, it's for inference. So the inference time evaluation, whereby now so our approach of deploying this model is the model gives us the response, but the response is not sent directly to the moms. So we don't want the LLM first talking to the moms directly. We don't want that because of ethical issues and maybe some potential hallucinations, assuming if there will be any potential hallucination. So we don't want it talking directly to moms. So we want to have that human check. Remember, the goal here is first to actually reduce the response time. So as I mentioned, so the response time for urgent cases is like 5 minutes, and we want to reduce it to maybe less than 1 second, or less than 5 seconds. So what happens is the model generates the response, it goes to a help desk. So the help desk now reads the response. So they get a template response, and then if it's okay, they can send it, all right? So they'll annotate satisfactory, or they will edit it, maybe for it to be satisfactory, or they will discard it, annotate as for discarding. And this allows us to also collect more data. So it acts like a form of quality control, a feedback loop, and also allows us to also explore areas where we can do full automation, maybe categories which you can do full automation versus partial automation. And then it also allows us to prepare maybe for scalability. And lastly, this kind of data is also very useful for our late iterations of maybe aligning the preferences of the model. So these are the different results maybe you have been able to extract using our JH English MNH data. Now, maybe something to note is on BAT score. So when you use BAT score, sometimes you have to specify the model.
It ended in November. Yeah, it was 1 month.
Hello, sorry. Yeah, so yeah, so I was talking about the different metrics we use, the autoval metrics, but here we are trying to evaluate our validation data, and that's only the English MNH data across these different models, and we are using the metrics BAT score, blood, Meteor, and blue score. But as you notice for BAT score, actually what we notice is that when you use a model, because in BAT score you can select a model. So when you use a model such as XLM, Robata, or even BAT itself, what happens is this scores will be very high. It's going to actually get to 90s and 80s. But we want to represent the true picture. And for BAT scores, so what we did is we have our own contrastive learning model, which actually knows maybe just the vectors of words within the MNH domain and the different spaces, the embedding spaces. So it's the one which we use so that you can just get a very good representative BAT score, which allows us to evaluate the different models. So you can see that this is UlizaLlama Mistral and also UlizaLlama Llama. Yeah, they are performing quite better than these others. So this is for Swahili, and as you can see, of course, for Swahili, Girmaw, Mistral, and Llama 7. So if you do not fine tune them, actually, you are getting very poor blue scores and Meteor scores, which are very, very poor. But as you can see, the UlizaLlama, UlizaMama, which is the Llama version, and the Mistral versions are actually performing better. So these are translation baselines. So we said it's not fair to actually evaluate these models on just MNH data, which has our own preference data. What if take our Swahili data, translate it, and then put them in the same pedestal? Because these are large language models, so they should be able to address maybe some of these MNH questions quite well. So we translated our MNH Swahili, so validation data. That's the questions and the responses. And we now evaluated across the different models. And of course, these UlizaMama and UlizaMistral are performing way better. So for getting evaluation, now this is with the tokenized extension, and you'll see that there are issues there actually. So you can see that this is the Girmaw, Mistral, Llama. You can see how they are performing quite well on these benchmarks such as PubMed QA, MEDEMS QA, Med QA, and MMLU General. And also UlizaLlama, which which is our Swahili fine-tuned Llama. You can see how it performs compared to actually the fine-tuned version of it. You can see actually for something like PubMed QA, it maintains the same performance. For MEDEMS QA, there's a drop in performance, but for MMLU General, it performs better. Maybe it's because of our instruction fine-tuning data, but this is with tokenized extension. So without tokenized extension, what we expect to see is that this kind of performance.
Sorry, it looks like we are losing Stan.
About now?
Stan, Yeah,
Sorry.
we can hear you, and your talk
Yes,
is
you can hear me now.
Yeah, and your talk is quite exciting, and you're left with like 2 minutes.
Exactly.
Okay, thank you.
Yeah, 2 minutes out. Yeah.
Okay.
Just
Okay.
But just before move to the inference exam.
Yeah.
All right.
Think
You
we.
cannot. Sorry.
Yeah, we can hear you now.
All right. Okay. Yeah. So these are just some inference examples. So as I finish, so like you have this prompt. So
I think your slides didn't move.
Okay. 1, 2. What about now?
We are still on evaluation,
Okay.
like in context
Okay,
learning.
let me. Okay, just 1 second as I finish, and sorry for taking a lot of time from current slide. Okay, so these are the inference examples. So we have this prompt. So why am I experiencing bleeding while pregnant? Actually, it was sent in Swahili. So for those of you who can read Swahili, and as you can see, this is what our MNH model suggested. So bleeding during pregnancy is a dangerous symptom and needs to be checked by a doctor. It occurs most often in the first trimester and is often a sign of miscarriage. So in the second, so it also explains in the second trimester what this could mean. It could be a sign of placenta problems or irritation of the cervix. So if you're bleeding, go to the hospital immediately. Then this is a question on someone is asking, I have stomach pain and diarrhea, which medicine should I take? And as you can see, this is the response which the model is trying to give. So actually, the questions are asked in Swahili, so I'm trying to do the translation for the benefit of everyone who is in the meeting. So when you ask it to prescribe a medicine, so it says it's important not to take or swallow any medication during pregnancy without a doctor's prescription. So please go to the hospital whenever you feel ill so that your doctor can recommend treatment methods that are safe for you and your growing baby. So thank you so much. If you want to contact us, so please use the emails below. Yeah, thank you so much, Millicent.
This is excellent work. And would you please like reshare again so that as we are taking 1 or 2 questions from the audience, we can see your very last slide. We didn't get to see anything. So reshare again so that we can see your last slide, and then let's take questions. Yeah, so as Stan has mentioned, he's working on a paper around this, and he's asking for our feedback so that he can add our input as well to his paper. I think that would be really great. I wonder if we have questions there. So we'll take 1 question and from the people that are in the NPR, and 1 question online. Stan, how can we send you this feedback to add to your paper through your LinkedIn or something?
Yes, either or let me actually share my email again. Sorry, I think I'm in the wrong slide. Yeah.
All right.
Yeah.
Thank you very, very much for quite an excellent work that you're doing for Jacaranda Health. This is really impactful. So let me just read for you a question from David, as maybe members in the room are preparing. What are the semantic evaluation scores of like GPT-4, GPT 3.5 or other LLMs, and how do they compare with Mama, Mistral or Llama? But by the way, did you try GPT OpenAI models, basically?
okay, we have not tried actually OpenAI models,
Okay.
but yeah, we'll also do that evaluation when you're also trying to publish the paper. So the semantic evaluation scores using our GCM GPT score, mostly for our own model, we were getting around 9 out of 10. But yeah, we'll share more of these in the paper because I've actually not documented that. I can see Mohammed there, my mentor.
Perfect. So I wonder if Mohammed or Clement, you have a question, you can please feel free to unmute and just ask. Otherwise, yeah, over to members in the room. Oh, Mohammed is actually in the room. Okay.
Hi, Stanslaus.
Hi.
Hello.
Congratulations for the good job. So I've
Thank
got two quick questions. The first question is, why did you use causal language modeling as opposed to mixed modeling? Then second question is that given that you are using a low resourced language, Swahili, how did you annotate medical terms such as preeclampsia, given that you are merging the two, you're merging Swahili and English? And then lastly, okay, you presented talking about these women in the marginalized areas getting text messages. I cannot see them querying your model to generate the dynamic content. Thank you.
Very good questions there. Yeah. If you don't mind, maybe I'll start with the last one. So, and maybe that's how infrastructure works. So the moms actually are going to receive the message. They are going to text on SMS, and they are still going to receive the response from the model via SMS. So this is actually how it works. So we have like APIs which connect to the cellular networks. So using the Africa is Talking API. So I think it's very popular. AT API. So that's what we use, and then we use the webhooks to actually connect to the model. So the model is deployed as an API. So the responses come from our Salesforce, goes back to Rapid Flow, and then they are connected with the AT API to deliver them as an SMS. Now, the other question was on why causal language modeling and not mass language modeling. So this is a generative task for most generative tasks. So it's either you use maybe both encoder and decoder and layers, or just use the decoder layer. So since it's a generative task, so causal language modeling allows you to have that kind of learning of trying to learn how to predict the next token. Whereas in mask language modeling is you're trying to predict just the mask token. So it's very good for things like classification. So for instance, our classification models are all mask language models, but our question answering model is a causal language model. Then how does the model learn how to deal with difficult terms? So one of the ways of trying to do that is that this continue pre-training, because it's being pre-trained using the data which we actually have from Jacaranda. It's able to actually learn where preeclampsia actually appears within that embedding space. So it's that continued pre-training and also fine-tuning allows it to actually even relate preeclampsia with something within that space.
Thank you very much. And we have to start our panel session exactly 5 p.m. Also, Stan has an exam, so we'll have to excuse him to go. I know we have lots of questions in there, and even via the online. So let's reach out to Stan via his email or his LinkedIn. His email is, Steph has just posted on Teams chat. So yeah, thank you once again, Stan, for quite an exciting talk, and this is great work that you're doing for Jacaranda. And let's clap for Stan once again. Thank you very, very much.
Thank you so much.
Yeah, so at this point, we will move straight to the panel discussion. But then before that, let's stretch. I mean, for the people in MPR, let's go grab some glass of water and then come back exactly 5 p.m. We will be starting our panel discussion. Is going to be quite an exciting deep dive into AI for all, moderated by our own Girmaw, Dr. Girmaw from AI for Good Love. And yeah, I can't wait for that. And unfortunately, Dr. William Ogalo is not going to join us. I will try to sit in for him, and also just to balance the gender gap in there, I will be there to like be with Kalika on the bench. So please stay tuned, and yeah, let's have 5-10 minutes break. Thank you very much. Over to you, Sam.
Thank you. Housekeeping briefly, in case you need to use the washrooms. Just immediately on the left is an entrance there. The immediate right is for gents or males, and then Opombele Kidogo on the left, ladies. So yeah, someone will be around there to buzz you out or buzz you in when you're coming in. So cool. So let's take about 10 minutes break.
It's 10, Sam, 10. We are coming back exactly 5
p.m.
We'll
5 o'clock.
And then, yeah, 5:45, we will be done with the panel session. Thanks again.
So that at least That's how I get started. And actually, it was So since you said guys, that's what's bye bye. So I like something. Yeah, I understand. What's for that? Oh, very good. Yeah. Just some snippets. Yeah. I'm quite sure that this guy, I'm
I think we can come back. Can we please come back so that we get started in 3 minutes? The room is muted. Girmaw, in case you're talking, the room is muted.
Can you hear us now, Millicent?
Yes, perfect. Thank you very, very much. Yeah.
Can you sit?
I'll just stop sharing so that you can see Kalika very well, probably myself.
What do you think? You also. All right, Millicent, Kalika, can you hear us well? See us maybe on the screen? Perfect. Everyone seated? Perfect. All right. Hi, everyone. Good afternoon again. My name is Girmaw, and I will be moderating this panel discussion. I work for Microsoft again. I lead the AI for Good Research Lab, which is as a research lab other than Mari in Microsoft. And I am excited to be here to talk about AI and equitability with a focus on generative AI today. So I'll just kick off the panel. Again, thanks for joining by giving you a chance to introduce yourself and your work related to the topic we discuss, AI and then especially generative AI. I will start from Dr. Labi.
So yeah, again, my name is Lavri Labi. I am a data scientist based in Berlin and Nairobi also. So basically, what I'm doing in Berlin is advisory of management on digitization and automation. So I am, we're working a lot also in that context with generative AI. For automation, and therefore my daily work is related to the topic here. So also in Kenya, we also supporting companies on that journey of automation and digitization. However, most of the client of Revolution Analytics are actually outside Kenya, which made us proud because the quality of the implementation coming from Kenya is trusted beyond the border of Kenya. And this is something that we like to scale up. And our objective also with Revolution Analytics is training student by implementing projects and implementing a real world project and mainly high level projects. So we have been growing the team since we have started, and we look forward to have a much bigger team.
Thanks, Dr. Levy. Gilles?
So my name is Gilles Hacheme. I'm a research scientist here at Microsoft AI for Good Lab. So I have some experience in natural language processing and computer vision, currently mostly working on leveraging satellite imagery for food security, climate action, and other societal challenges.
Hi, everyone. My name is John. I am a research scientist at IBM Research Africa. My work mainly revolves around looking and working with data at the subset level. So we try to find patterns and apply this idea of looking at data at the subset level to different problems such as detecting bias, out of distribution detection. And recently we've moved to applying this idea to the activation space of deep learning models, which is, related to what we are talking about today. So if you think about a generative AI model, in 3 steps, starts with a prompt or a question. That's step 1. On the other side, there are some outputs. That will be step 3. And step 2, there's a lot of transformations that happen to the input so that you can get an output. And we're now trying to see whether these ideas can show us patterns that can help us find things such as stereotypes and bias in these models. And yeah, happy to be here. And I used to work with Girmaw.
Great. Bias is a great topic. It's by design. Let's first the in-person ones, and we will jump into Millicent and Kalika. Maxamed?
Hi, my name is Mohammed. I'm a researcher in Bari, but I'm also a researcher in Microsoft MSAI. My team leads what's called Copilot synthesis and evaluation. What that means is that when we interact with the Microsoft Copilot, we're interacting with the output of our stuff, and we're responsible for evaluating it. And this is important because we're doing it from Nairobi. So going to Lavri's point, it's a testament that world-leading work can be done from here.
Perfect. So the online panelists, Millicent, can you start introducing yourself, and then Kalika?
Thank you very, very much, Girmaw. Hi, everybody. Again, I'm Millicent Ochieng. I'm a data and applied scientist at MARI, presently Microsoft Research Africa here in Nairobi. My current research is focused on generative AI, particularly large language models, and I am currently focused on or basically interested in evaluating the model's capabilities in processing low resource languages, especially African languages, which is so dear to my heart because, you know, the models are just, the languages are just so far from achieving parity with English. And so that's quite an interesting space for me at the moment. Thank you very much, Girmaw.
Thanks, Millicent. Kalika, please.
Hi, I'm Kalika. I'm a researcher at Microsoft Research Labs in India, where, in a couple of months, I'll be completing 18 years. I've been working in language technology for more years than I can care to remember. My work has largely been on, low resource languages, but also marginalized communities and how they use language technology. And I work in both the NLP group and the Technology for Empowerment group at MSRI. And currently we are very focused on a project called Bellum, which basically takes generative AI as the base of a platform, and we are building tools and capabilities on top of it so that people can build applications for societal impact on top of Vellum. So that's where my focus is right now. And I also work with Millicent and Mohammed on evaluation and other things.
Perfect. Thanks, Kalika. We will come back to the evaluation part, but I want to stay there with you on first understanding AI and equity, inclusivity. I know we are here to discuss about what are the challenges, opportunities, but to make everyone on the same page, what do you mean by inclusive AI and its equity for all? Given the complexity AI space has from data perspective, from model design infrastructure, people giving data for it, and policymakers making decision on the output. So AI is quite diverse and complex, but when we say inclusivity, what do you have in mind?
So when I think of AI and equity, I basically have a very simple definition in my head, which is that AI should be able to work for everybody across the planet equally, right? Like if I take an example from the language side, since I'm a language technologist, my go-to framing is that everybody should be able to access technology, whether it's AI based or not. But here we're talking about AI. So everybody should be able to access AI based technology irrespective of the language they speak. So irrespective of, their socioeconomic conditions, which part of the world they belong to, what gender, they should be able to access technology to make their lives better. So that's my definition of equitable AI.
I think we can agree on that. You said you worked closely with Millicent and Mohammed already, and you have done extensive evaluation of some of the models. And what are your findings compared to the definition you gave us? Maybe you could start and Mohammed or Millicent could complement us.
I think we're very far away from my definition of equitable AI. I always think that once we reach there, what I define as equitable AI, my job is over. But I think I still have a lot of work to do. And this is not only recent, but recently it's become much more important that we evaluate across all these languages for all these tasks because of the way generative AI is disrupting everything that we know about the technology landscape. And we are quite far from achieving our goals of in Microsoft, we say empowering everybody on the planet. And the way languages work for different tasks for across the globe, etc., is very, very skewed. And I will let Millicent and Mohammed also weigh in on this because they've also worked a lot on it. We obviously see that the kind of results and the kind of exciting generative AI outputs that we see for languages like English or French or German or Spanish, languages in, say, Africa or in South Asia are very far from that level. We have a lot of work to do. And this is a little bit language dependent and a little bit task dependent. But on the whole, we can safely say that we are very far from achieving parity with even the top 5 or 10 languages that are there in our list. Yeah.
Perfect. Mohammed?
Millicent, I can see she's wanting to say something.
Millicent? Mohammed says, I can see you want to say something.
Yes, yeah, but I would have also said it after Mohammed, but let me just go ahead. So like Kalika said, AI for all is basically democratizing AI for everyone, right, regardless of gender, and not just for some selected few individuals. And like she has said, we are not there yet. And from our evaluation question, Girmaw, that you've mentioned, when I think of AI for all, I think of two things, accessibility and representation. So from the models that we are having right now, these models are lacking something called representation in their training data. And that's how we are arriving at the models not working really well for South Asian languages or African languages, like Kalika is saying. And to add to that, you'll find that some of these models are actually achieving some quite good score, but when you take a look at their interpretation or what they produce as their output, for instance, for a machine translation model, you will be shocked that it will not be an output that is more cultural, it doesn't even flow with the culture of that particular language. So that's also something that we are lacking with the models that we are having. And for something like accessibility, right, we are still far from ensuring that for instance, speech models, are accessible to all. When you look at something like accent, we are still not having models that are able to detect accents for everyone on the globe. So yeah, that's what I can add to Kalika's point. Thank you.
Perfect. Mama?
I think both Millicent and Kalika eloquently covered the core issues, starting from what does it mean for this thing to be equitable, meaningful for people. But if I'm to play devil's advocate, which I'll do for the moment, I think back a couple of years ago, for example, we started Stanislaus's work with Gilles here, actually. We weren't interested in language representation. We were interested in representation because language representation was just so bad. So what we wanted was to be able to learn feature vectors that would somehow either be meaningful to each other so that we can do simpler things like clustering and hierarchical organization and so forth. And then jump forward 2 years later, and we're seeing really impressive outputs in what some of these models are able to produce in very sort of limited domains. And I think this is where it gets interesting, which is we know that these things aren't able to do everything that they're able to do. But there are some things that we can get them to do that are useful for us. And it's mining that space and understanding what is that space where these things are useful for us and pushing those boundaries to extend it and to apply it. And I think that fundamentally that's also related to a chicken and egg problem, which is usage. The closer we can get these things into the people's hands and more people's hands and diverse people's hands, the more use cases and the more needs that we're going to see. And then we'll be able to start to pick out things that we can actually make the things that exist today work well on. And I think it's important to differentiate between where we want to go to, which is the point that Kalika is making. If Kalika's point is sort of achieved, all of our jobs are these things are now actually benevolent and meaningful for people. Yeah. But how do we get? That's the question that we really should address.
Perfect. I think that's great perspectives so far. The speakers are working for Microsoft, big corporate. Lavri, what do you think? Inclusivity, because you touch different ecosystems, including startups, and what's your perception in that area?
Okay, I think related to the points about AI for all, so equity in AI, I think the colleague have seen everything about it. There's nothing I can add. What I would say is how we can get there. As one aspect is the representation of, let's say, data from the underrepresented parts of underrepresented communities. But for me, more important is that the people from this underrepresented community in this data set are also involved in developing this kind of models. So look, if I tell you why we count from on the basis 10, 1, 2, 3, 4, 5, 10, 11, 12, etc. So we are counting on basis 10 because the human being just stood up, he has 10 fingers. So he defined how to count based on the finger he has, based on his environment. Meaning, it's look objective, but it has a lot of subjectivity, mathematics and algorithm and so on. So many of the solutions which are developed now, they are developed based on the background and environment of the people who have developed it. And so even if you put the data apart, but you need the people for this, let's say from Africa here, also to be involved in development. Maybe the performance, the loss function we're using now can be made better if the context of the African people are taken into account, or of the Indian people or whatever. So I mean, the fundamental research about it, taking into account the social environment, is eventually something important here.
Perfect. Thanks, Lavri. I guess so far we have a common ground that inclusive AI means, as it has been mentioned, a technology that works for all, accessible by all. And I want to finish the conversation with what are the opportunities. I could sense most of you are here from the academics, students, and professors. But before the opportunities, we need to discuss what are the challenges, the bottlenecks. Because sometimes I see, oh, these models are not really working for African language, but Mohammed already mentioned that there is still certain things they could do great and we could narrow the gap. So the second point of the conversation is what are the challenges at the moment now? And I could classify that as sort of people versus model technical infrastructure, which John mentioned as bias and so on. Maybe let's start with people working on it, representation. And I know Gilles and Millicent has been, including Mohammed, working on this Africa-focused natural language processing community. So what was the challenge? What did you work on that aspect? And then we will come back to John to discuss about some of the technical evaluations and understanding of bias. Let me start from Gilles, actually.
Yeah, thanks very much. So I think, I mean, most of the things I will talk about relate to Masakane NLP, which is a grassroots community working on, I would say, reviving African languages through AI. So first of all, when we talk about building AI solutions, the first raw material is data. So no data, usually no AI. I mean, of course, there are cases where you can do simulation and so on, but in real life, you need real data. And when it comes to African languages, almost none. So I grew up in Benin, West African country, west to Nigeria, if you don't know. We have more than 70 local languages. The main one is called Fongbe, but it is not taught at school. Okay, so if you want to understand anything about it, you have to figure it out. We learn French at school, but at home we speak Fon, which we can't write. So meaning that there is no written resources. So when you want to train a machine translation model, like for someone, just imagine like our parliament votes laws in French, and a lot of those who can't go to school don't understand French. And those laws are applicable to them. So if you think about just building a machine translation model to translate at least those texts in French to form, because there are a lot and it's hard to have humans to do all these. At least they need to be assisted. And you want to build a machine translation system, there is actually almost no data, or this data exists, but is locked somewhere, not digitized and so on. So if you want to build any application, you have to start with, let's say, how do we gather that data set? What Masakane has been trying to do is trying to reach out to different communities across Africa, trying to bring linguists, trying to bring in machine learning expert engineers, I mean, from different levels, from students to, I mean, even professors, and say, we need to bring all these resources together to build something. And yeah, we tried, we built some data sets to start with. Building data sets is not usually the most exciting part when you think about AI, but it is I would say, most foundational work. African languages won't have proper LLMs if we don't have raw data, if we don't have communities generating those data, if we don't have media generating those data. So we try to build the data set from the community, but it's still some small data sets that we can try to use to build specialized models. So yeah, there are still a lot of work to be done in that regard. We are still far from the point where we can say we have a fair, I would say, amount of data we can leverage for AI in for African languages. But yeah, the work has started, and anyone who wants to be involved is welcome.
That's great, Gilles. How many of you know Masakane community or deep learning in Dawa? Can you raise your hand? Perfect. Yeah, this is just to mention, similar to what Mohammed mentioned earlier. AI is here, it's a capability. What we could make out of it is also depends on every one of us. And someone mentioned recently, actually, in the US, the big corporates define the conversation of AI. In Europe, it is European Union and others. In Africa, it is a grassroots community, which is Masakane and others are a testament. So this is just to say, if you are interested in AI, you may not look for big government budget or big academic institutions, but there are communities working across different AI domains, whether it's natural language processing, computer vision, AI for healthcare, AI for education, and so on. So that's just a point to remind most of you. If you wonder about AI, a particular domain here, check if there are communities, and most of them with Africa spirit, of course, they are open to work as a community and so on. And this is not just a community. I would say Masakane has been shaping NLP research in the continent, and they published in a lot of different journals and venues. So that's something to consider. John, once we have the data, we have the models. Usually when we evaluate how good a model, how equitable it is, of course, no data, no model is perfect. And sometimes it works for certain segments more than we expect, or certain segment of population the other side around. And I know your research work was trying to understand how these models are performing. And could you share some of the approaches and use cases you have been working around in understanding the equitability of actually AI models overall?
Yeah, so when you ask the question, or typically how this goes in research is when you have a model and you're trying to evaluate it against some outcome, such as bias, right? Researchers will start with the question. For example, I want to know whether this model is equitable or is unbiased, or so on and so forth. And they will look at this data. They will start with the hypothesis of, for example, saying we want to know whether this model is fair to, let's say, a particular gender or a particular race, and so on and so forth. So some of the work that we do is trying to change that question, and instead of starting from some predefined, features or data points where we want to evaluate how a model is related to some outcome, we switch this and ask the more general question, which is, show me where this model is, for example, making the most mistakes, or show me to which subpopulation of a large population a particular model is biased against. And this is key for two main reasons. One, by not presupposing what you think is happening in the model, you open yourself up to learning things that you wouldn't have if you started with a predefined set of hypotheses. And two, the way in which we do this discovery and looking at data at the subset level is very efficient and very fast, which couldn't be done if you start with the hypothesis. And this way we can, for example, show connections between things that would typically not be evaluated. So right now people say, we think AI doesn't work for this community. we think it doesn't work for the other gender, and they will perform studies to prove that, right? But if you start from the other direction, then you might actually find subgroups which you didn't know existed before. And those are some of the things we are trying to advocate for with the advanced techniques that we are doing with looking at data at the subset level. Yeah.
That's great. I mean, goes back to what Kalika mentioned earlier. If we want to understand AI works for all is like all people, all use cases, and how we cluster them is really a tricky question, because people, Gilles already mentioned there are more than 70 languages in Benin already. And when you say people, gender, age, education level, urban, there is such a high dimensional variables to characterize them. And usually even in the papers you see, oh, let's understand bias. Let's check it versus male versus female, old versus young, and that's it. But we know that even in this room, there is that complex dimension of identity and person. And what you said, trying to understand people cluster, we don't know even they exist, right? Because there are things may perfect fine if you evaluate it just based on gender, just based on one as a variable and another variable. But if you try to combine this intersectionality, there could be some variables or segment of populations that are left behind. This is similar to, I think, in the US when they try to do this civil rights movement. You may have law just for Black people. You may have law for female, but when they are Black and female, it's a different category and the challenge is different, right? So overall, that's just to say, when we try to evaluate AI model and data, people you think are quite complex, and we need to have that understanding of evaluating them. By this, I will finish the second theme, which is challenge. Now the good part. I will start from John. What is opportunity? It's the topic, the domain is changing quite a lot. I remember a year ago when we talked about language models in African problems and context, it was a bit blurry. Now we see that a lot of advancements are already there. Going forward, given most of that things are from academics and so on, what is your insight about potential opportunities for you, us, and everyone to explore? And then I will give the mic to Mohammed.
Yeah, so in the next few years, right, I think a lot of us agree that AI will be part of a lot of the way we do things, the way we communicate, the way we work. And this comes with a tremendous amount of opportunity. I mean, there are risks with, for example, people thinking that AI will replace some jobs and so on and so forth, but the opportunities are, in my view, greater than the risks. But for a specific context and the way in which we can leverage AI to, take us to the next level, you can see that by leveraging this type of technology to core things such as, let's say, healthcare, say education, it means we can democratize a lot of expertise which was previously only accessible to pockets of people who live in developed nations. And if you can, for example, from wherever you are, get access to AI-driven, education or healthcare, then this is a good thing for all of us. And again, going back to the issue of equity, of making sure that the benefits of AI are accrued to society as a whole and not to specific groups, where we are going and the types of opportunities that are coming with, LLMs and applying AI to medicine and so on. I think these are the types of things that we will have to jump on so that we are also not left behind.
Perfect. Mohammed?
Thank you. I was thinking about the question as you were speaking.
given all the challenge we go through, it seems small.
I don't think I have the depth for it. So I'll take it down in two ways.
Yeah.
One is the way that we use technology at the moment is as a feature to scale us, to enable us to do something that we have other barriers that don't necessarily enable.
Yeah.
A good example is the NLP mediated healthcare. And if everybody has an access to a doctor in a 15-minute walk, as you do if you live in Norway, then the need for that just plummets. Whereas if you don't, then you have a problem that you're trying to sort of provide a solution for. So I think there's spaces where this kind of technology as an enabling and a scaling tool becomes really interesting, which takes me to my second point, because I want to pick on Kalika, who does, because the other half of Kalika is looking at communities and people and how people utilize technology. And I love mining her thoughts on this, so I'm going to pass
All right, Kalika.
Yeah, I think the opportunities are immense. We have like a really, really powerful tools. Well, people who've been like doing this NLP stuff for a long time know how long it took us to just build, a possible model that could do the things that the generative AI models do. But the thing that I cannot stress more is you really need to understand the communities that you're building for. You really need to involve them in the process, because we sit and we think, okay, data is the problem, a model bias is the problem, etc., etc. What we do not understand is that bias works so differently depending on the community that you're working with, right? So if I give an example of India, we've just finished this one study in which we were looking at basic gender bias and the definitions of gender bias, the data sets that are available to the researchers and the community to kind of label gender bias do not work for India. The culture is completely different. Right, the data, even if you translate it, have the best translation systems and translate it from language X, say English, French, whatever, to an Indian language, it loses any meaning whatsoever. Those contexts are not relevant for our communities. So you really need to understand what is it that is important for the community. And the only way that you can do that is by having the community involved in it. And otherwise, also, if you look at it, like one of the things that we did was, we are still working on it, is a Shiksha bot. This is an education bot, which is for the teachers, not for the students, because we believe that if you empower teachers, then that scales much more. More students are affected by one teacher who is able to use technology effectively, right? And there, before we even started working on this, we did a survey of 100+ teachers from across the country, trying to understand what their pain points were, where they had difficulty accessing, where they spent a lot of useless work and effort, which they could use in other ways. And that all went into, the way we built the Shiksha bot. And, the main thing that we worked on that was like the lesson planning for teachers, because that's really something that they spend a lot of time on, and that could be done very effectively by Gen AI. And just to show you the opportunity there in this example is that now we have a system based on generative AI, which is able to create a lesson plan for a lesson, assignments, class activities, homework, everything which can be customized by the teachers based on the inputs of the teachers in 7 minutes, literally in 7 minutes. Right? So this is the opportunity that we have. This is the immense power of the tool that we have at our access, right? So I think we are at a moment where we can really be very, very disruptive in a positive way. but we have to understand what is it that the community wants and have the involvement of the community. This cannot be done by, some researchers sitting in an ivory tower and thinking like, okay, this score, how to optimize the score for 0.5% more, etc., etc. You really need to focus on the community. I'm sorry if I'm sounding like very repetitive, but I just feel very strongly about this.
If I can add to that, something that sort of sticks out from this discussion and presentations that we have, and so it's the capacity for the technology to fit in. And the question is, what is the need? Doing an optimization, you need to really go, where is the greatest need? And this is where it becomes interesting. The places where these technologies can have a transformative or a very hugely magnified impact are the places where the need is the largest, but typically they're the places that are furthest away from it, both socioeconomically, educationally, access to it and everything else.
Yeah.
And it's bridging those gaps that becomes really difficult, and the challenge from what this discussion is saying.
Yeah, yeah. I cannot stress enough on the importance of understanding your community. We even at the AI for Good, we try to do every project with partner on the ground. If it is conservation with Kenya Wildlife Trust, if it is agriculture, the Agriculture Ministry, or people working on the ground. Because at the end of the day, these are the people who knows the problem better than we, the researchers. And these are the people who are going to use the solution after all. And then usually, even in Africa, I came across many students doing master's PhD project. They say, I'm doing this for cardiovascular disease diagnosis with AI. And I ask them, did you check with clinicians or did you talk to patients? No, just because the data set is available by some university in the West, it doesn't mean that you can just pick that and expect it to work for a Kenyan patient, right? So that's what we mean by understanding the community. I know time is up. I would love to have Millicent and the Gilles to come up, but I don't want to finish this panel discussion without giving the audience a chance to ask a few burning questions. And I'm sorry, Millicent, Gilles, and Lavri. Okay, quick one.
Okay.
In the meantime, let me see some. Okay, go on.
About the opportunities.
Yeah.
As there's one thing which is very interesting and very important that generative AI bring us. Transforming unstructured data in structured data, right? So we have, for example, a project where police and students' policies where on paper have information that which are not in the database. Using generative AI, you are able now to get more information which were, let's say, quote unquote, not digitalized. It's an opportunity that to build solution based on data which were not available before. For example, the problem Gilles has, it might be eventually solved that way. There are no texts available, but a lot of videos are available. For example, in Ivory Coast, we had news in the different local languages. So they are available at the television office and so on. If you use now a model that at least translates these videos in phonetics, and from phonetics translate in the way you want to write, you have the text. And this is a great opportunity that a lot of hidden data are now available to create all kind of products. Thank you.
That's a great point, Lavri. Because if you go to the different governmental organizations and all others, they have been collecting data in some way for many years, but how to transform that into usable format is a key challenge. And good that you mentioned that opportunity from generative AI. All right, any burning questions on AI inclusivity, challenge, bias, and opportunities? Let me share my mic.
Great. Girmaw, we have a question also from Professor Nick Bidwell online. Could we take that first?
online one first. Sorry. Both, Kalika.
Hi, can you hear me?
Yes.
Hi, Girmaw. Hi, everybody. Thank you for great presentations. I'd just like to riff off Kalika's comment about how bias means different things in different places in different cultures. And that goes for pretty much any of the ethical issues that we would consider, whether that's ethics in its relationship to trusted systems, or whether it means what we all mean when we say accountability, transparency, whatever you like. So what do you think is the best way, given that we all have an expertise in our own language, whether that is our AI language, our HCI language, our particular form of AI language, or our home languages? What do you think is the best way, anybody, to get those things to work together, considering you have to accept we will always understand it all a little bit differently? What do you think is a good way to go across those translational problems? Africans are brilliant at this, so I'm expecting some great answers.
Right. Shall we take another one so that we could address together?
Okay, thank you so much. A really great session. Mine is on inclusivity. As I look at the generative AI, according to ITU report 2023, we have around 2.6 billion human beings on Earth who are not connected. And here we are talking about generative AI, and just looking at what my friend from Benin was talking about, what are the opportunities available for these people, the 2.6 billion who are not connected? What can we do differently to ensure we don't widen the gap?
Perfect. I want to get one question from our female attendees. That's fine. Okay, that's yeah.
My question around inclusivity. I think you mentioned that one way to be more inclusive is to allow the communities to participate in the development of these in development of AI. And I was thinking, like, one of the major barrier to many communities to participate is the cost, for example, and the access to resources. And I think a lot of companies are investing like in the tunes of billions of dollars, which are inaccessible to many of these communities, and they end up centralizing the research. So I was wondering whether there are any opportunities know of, or any work that is being done, like to explore other techniques or algorithms in AI that may not be as resource or data hungry as the current state of the art that are being used in LLMs or other areas.
Perfect. One to start.
Sorry, Girmaw, I can't even hear what you said.
Now we time to address the questions.
Sure.
You can start. Yeah.
I can start, and I love Prof's question, and it's the one that I was going to start by addressing. So in terms of strategies that we can use to overcome bias in large language models, right? I just have like one that usually is in my mind, which is like holistic evaluation, right? We won't know where the problems with our models, generative AI models, are until we get to evaluate them, until we get to assess them really well, to get to know where can we improve, right? So we cannot change, or we cannot improve it not unless we get to know what is happening. So I would always go for continuous monitoring or continuous assessment of LLMs in whatever area that we will have deployed it. Getting feedback from users as one key area to always overcome bias, like getting the feedback and coming back to resolve the issue. So I wanted to talk about like evaluation as one way to mitigate bias.
Perfect. Kalika?
So I think one thing that I'm not like that aware of the African context, but at least in India, the government is putting in a lot of effort and lots of resources into AI development, which is contextualized to the Indian scenario. And I think like when we talk about large companies, etc., see, they are commercial entities. So it is in their mandate to go after where the dollars are, right? But there are so many things, like Masakane is like just such a great example. We are all like in NLP, like absolutely big fans of Masakane. But there are also like government initiatives. There are funding agencies like the Gates Foundation, GIZ, etc., who are funding data collection as well as development of certain algorithms and everything. So I think one should look to everything depends on a champion, really. So if there is a champion and somebody rallies around, there are resources that are available. It requires people in the community to kind of get into the mode of like wanting to do this. And that is only possible if they think there is a need for them to do this, so there is a need versus desire kind of a thing here.
Perfect. Thanks, Kalika. I have such an urgent meeting. I will be out, but I want to give a chance to Gilles for the second question. That was connectivity. We talk about AI access equitability, but the connectivity of people digitally, even electricity for that matter, is very questionable in the global south. What's your take on that? And I will leave Sam to take over the moderation. Yeah.
Yes. Thank you very much, Girmaw. So we've talked. And we used to talk a lot about, of course, devising a model, trying to have better data representation. And true, if we don't have the data, how do you want to balance it? Sometimes we duplicate, like we have maybe, I don't know, over 100 sentences, we may have 90 in English and maybe 10 in Swahili, and then we try to duplicate the Swahili sentences, or maybe we reduce a little bit the English sentences, and so on. We try with statistical methods to come with, I'd say, some kind of solutions, but they are not actual solutions. They are just mitigations. So the true solution will come from having enough Swahili data. And how do you get to that point? As you said, if people don't have, access to internet, how can they produce anything meaningful? If they don't learn their own language at school, how are they going to write it? How can you get that content online? Of course, and my friend was talking about something that I completely agree with. Like, AI can also help to correct some of these, I would say, foundational problems, like digitizing the resources that are out there and no one is caring about it. So we have a lot of speech in those local languages. How can we transcribe them automatically? And how can we leverage that information to, to go to the next level? So yeah, I think there are a lot of work to be done at a very foundational level. Most of the time when we speak, I think at a much higher level, because the foundational work requires a lot of resources, and then you need many different actors to be involved, from governments to universities to, communities. And that work needs to be done. Otherwise, in 50 years, we will still be discussing how to devise models to work on Swahili or other African languages. Thank you.
Sure.
Thank you. Just want to comment a bit. I have one comment about the problem with inclusion. Actually, already in Kenya, we have a big problem. As a company being in Kenya, operating for creating solutions for companies in Kenya, we have a problem that you have the data protection of Kenya that oblige you to keep the data of your client in the territory of Kenya. But we develop solution with cloud technologies. Most of the cloud technologies provider do not have server in Kenya. So you have a law coming out, but it not follow up with the possibility of doing it. I think at a certain point they have announced East Africa Data Center has done a partnership with I don't know who, but until now, as far as I know, it's not possible to choose region Kenya. So now you look at the generative AI solution. The colleague here, he has shown models, but what he was showing, it's 7 billion parameters. So he can deal with that on his computer eventually. But can he deal with the 70 billion parameters? It needs a cloud solution. Now, what is the data he has are not allowed to leave Kenya? How can you develop a solution? So we already have a problem here. Yes, Kalika mentioned support from GIZ and all these things, but even this GIZ in Germany, they are supporting their own companies in order to develop their own LLM solution for the German market, because they know how strategic it is to have such a solution in the hand of others. The same way a company in France has been funded billion before even they write one line of code, because of the strategic importance of that. Even China developed, everyone develops its own thing with their own mean. You cannot leave that in the hand of others. So as soon as you get the financing from others, we have gotten a lot of financing, not financing with GIZ, we know how it goes. As soon as you get financing from abroad, they dictate you their conditions. So I think it's a big problem for African country not to having a program to accompany companies developing this kind of solution. And can you imagine, we're talking like that about Kenya, but Kenya is the leader in Africa. Then imagine how the other countries are in Africa. So thank you.
Quick point before I close. I think, so there were 3 questions. The first one about bias, I think, was answered by Millicent holistically. The second one, I completely agreed with Girmaw. I also really wanted to hear what the question's friend from Benin had to say. But on the third one, which is what Lavri has been talking about, I just wanted to echo what Girmaw had said. It's true, we have a lot of financing problems, but to Kalika's point, I think in the West, it's the big corporations. In Europe, I think it's the law, and here it's communities. So just to reiterate that we should all try to, look out for communities that are trying to bring us to the global map, such as Masakani and Indaba, and those are the communities that will help us as, we wait for our government to get their stuff together. That's what I wanted to add.
I don't think everything's been said. Let me think. So I'm a great believer in entropy. What that means is that everything goes to disorder. So in practice, these things won't stay behind locked doors. I think the greatest example of entropy is the phone. I lived in Somalia in 2016 for a year, and I remember sort of traveling across the country with herders, and young men work as camel herders. So they'll take your livestock and they'll take it from A to B. They'll go for 3 weeks, whatever. they all have a Nokia 303 sort of strapped to their side. That's how they get paid. That's how they keep in touch with the world. That's how they're listening to the radio waves. It's not the laptop. It's not the fancy big GPTs that are the difference. It's the things that people do things with, the things that people utilize. So I think there's an interesting aspect of what entropy does in terms of proliferating technologies, devices, users. And frankly, models aren't interesting. Data isn't interesting. Complex loss curves aren't interesting. What's interesting is what people do with it. So it's what do you guys want to build and how do you want to get it out into people's hands?
I will allow one last question, then we wrap up, and I'll volunteer someone if no one. Yeah. Thank you.
Hi. Hi.
Go ahead. Yeah.
My name is Baraka, and I'm curious to see if we can reach a point where we can have offline AI, like AI models that maybe are light, powerful enough to be run on mobile phones so that you can cater for the 2.6 unconnected billions of humans. So because if they are unconnected, they can't access GPTs on the internet. So you can get to a point where they can save for offline, or it can be light enough to run on embedded devices. Are we at such a point, or will it take at least some years?
Go for it. Mohammed, awesome.
We're not there, but we'll get there. A good example of that is compression. When you watch a YouTube video on your phone, if you have to imagine all the way from actually the original video that was recorded by somebody to what comes to you, what you're going to see is an exercise in optimization. So your video gets re-encoded in 5 different ways. You get your HD video all of you the way down to your 200 by 100 pixel video. Why? You want to save on the amount of data that you have to transfer, you have to save the amount of storage you want to do, you want to save of the amount of energy that you want to use. And then comes a whole pipeline in order to get it there. Depending on what path that it takes, depending on what is being sent. Now, most things even do multipath TCP, which means that each packet is going to go in a different direction. All of that in order to reduce the amount of time that it takes for that video to come and land at your mobile phone. And then when it lands, it gets picked up by a whole host of abstractions, all the way from hardware decryption and hardware supported, what do you call it? The sort of expansion of the files to software-assisted tools that make you that fill in missing pixels so that you don't notice the difference. All that complexity is there in order to reduce the probability of you losing a packet and you not seeing that video that you wanted to see. And what it's done, it's miniaturized it. If you go back 15 years ago, you couldn't send HD TV on mobile phones, but today you can set it on the cheapest phone. So those kind of scaling changes are all going to come. They're not there yet, but when you're building, you should build with that in mind. It shouldn't be with limitation of, hey, I need to use GPT-4 today to be able to do that. But actually, what can I build that needs GPT-4 today, but can be scaled to work with whatever else comes tomorrow?
Any other additional comment? Great. In the interest of time, before I wrap it up, allow me to ask you to appreciate the panelists, both here and virtually. Thank you so much. You may be seated. Mohammed, thank you for agreeing to be volunteered.
Thank you.
Yeah.
Thank you.
There's always that route. Yeah, there's always that routine now that we are based in the African context, where we get an attendee to give a vote of thanks to the panelists and to the speakers. And I'll ask David Wamburu to do that for us.
All right, I guess this is how you're going to do it. So let's put our hands forward as yay. Oh wait, the ones who are online. So we are trying to do a clap routine. So hands about yay, what do you call it? Distance away from each other. Now 3, 2, 1. Again. Right. So I'd like to appreciate all the speakers, the guests, and also all of you for attending this lovely session. And thank you and welcome to future sessions.
Right. So thank you so much, David. He's a good friend, so I like ambushing him. And that's what happens when you have friends like me. You don't need enemies. Yeah. And yeah, as this is a routine, regular sort of seminar. So let me stand in the light because over there you won't see me. Yeah. Yeah. So every so often is Microsoft Research in partnership with AI for Good. We normally have these grant seminars. And so this is something that we'll definitely continue having. And so in the months ahead, our good coordinator, Millicent, let's appreciate her, by the way. I know you all will see some feedback from her. She's really been, she's been sleeping, but she's been working hard. You know, you say sleepless nights. No, she's been sleeping, but she's really had sleepless nights, really trying to get these to be a success. And we've all had a nice session. We've learned from all of us through the questions you've asked, through our guest speaker, Lavri, agreeing to come all the way from Germany. You're supposed to come, is it last week? And then you agreed to come a bit earlier. So thank you so much, sir. And also to the panelists, thanks for agreeing to join up with all of us, and also for all of us, for the questions that you've been able to ask. They say learning is a collaborative journey. And as a graduate of University of Nairobi, there's this thing in the University of Nairobi called the fountain of knowledge, the one that sprinkles water. But the reality is when it comes to humans, there's no human who is a fountain of knowledge. It's all of us working together, all of us sharing ideas, meeting up together. Even you look at all the advances in papers in Gen AI or whichever field, rarely do you get a paper that has been done by one individual that ends up being groundbreaking. It's all about collaborative effort, people from different backgrounds, sometimes different specialties coming together. And that's what really causes there to be growth. And so I believe even as we continue doing our research, whichever endeavor, whichever field that you're in, let's all go together, let's all work together. Just remember these, I like cars, so I like having analogies of cars. And one day I saw sort of a poster where there was a racing car and there was an old rugged Land Rover Defender 100. And the message on one was, it goes fast, the other one goes further. And I believe we want to go further. So we work together so that we go further together. And that way the impact is amplified. And as you can see, even from the panel, it's not Microsoft only. We believe in working together. We had people from Google, we had people from IBM, including my former boss, Skylab, though he was in front. But the other was my former boss. He's a good man. Right, and also people from academia. So thank you so much for making time to be with us, and wish you the very best in your Gen AI journey. And yeah, let's mingle for a few minutes before we are kicked out by the security team. Asanteni sana, and have a lovely weekend. It's weekend here. All right, thank you.
Thank you, everybody. Thanks, Sam. Thank you all our speakers again. Thank you all attendees at the MPR and online. I think at this point we will close the session, but we believe and we hope that today's seminar has provided you with, insightful perspectives and has inspired you to continue exploring the exciting possibilities of generative AI models. Have a wonderful day, everybody, and see you again in our next grand seminar. But we do host monthly seminars, and look out for our invitation. Thanks again. And I think we will end the call. And the people online, people joining us physically, please go ahead, network as Sam has mentioned. Thank you.